Okay guys, so in this lesson we are going to be looking at asymptotes and reciprocals, or reciprocals and asymptote if you will. So, reciprocal and asymptote. So an asymptote we already know about, they occur naturally when we take reciprocals. Okay, so we're going to keep these two ideas, so we're going to keep the following two ideas in mind, okay, when we're making these, because when we actually draw these things, we can draw them without actually working out what the function is. Okay, we can actually work them out by looking just at the graph. So the reciprocal of a very small number is a very large number. So for example, if you take, if you have a very small number, say like 0.00001, well, that's the same as writing it as, so the reciprocal of that is 1 over 0.12341, okay, which is the same as if we know we jump 5 spots as 10,001. Okay, so very big number. So reciprocal of very small is very big, and of course the inverse is true as well. So if you've got a very big value, the reciprocal is a very small. Now the reciprocal of a positive number is also a positive number, and the reciprocal of a negative number is also a negative number. So for example, the reciprocal of 3 is just 1 over 3. Both of these are positive, pretty easy. -2, the reciprocal is 1 over -2, or just -1/2. Okay, so I know they're pretty obvious, but they are actually going to help us a lot when it comes to drawing these. Okay, we can see these results using the rectangular hyperbola, so y is equal to 1 over x, which has a vertical and a horizontal asymptote. So remember, an asymptote is a line that your function approaches but never actually meets. So in this case, we have as x approaches infinity, so as x goes towards further and further and further to infinity, okay, it's never actually going to touch the line, but it's getting really close to the line y is equal to x, or where y is equal to 0. So remember, 0 is here, 1, 2, etc. So it's getting very close to 0. And as x approaches negative infinity, so from the other way, it also approaches 0 as well. So it's getting closer and closer and closer to 0. And it's getting closer and closer to 0 from the negative end. So it's actually getting, it's going up towards 0, whereas this one over here is going down towards 0. Okay, and as x approaches 0 from the negative side, so as x gets closer and closer to 0 from the negative, y is shooting down towards negative infinity, okay, just like that. But as x approaches 0 from the positive side, okay, so as it gets closer and closer and closer and closer to 0, going that way, my graph actually then shoots up to infinity that way, okay? So it's never actually going to touch it, because remember, we can't divide by 0, but we can look and see what happens either side. So to actually test for something is a vertical asymptote, in the denominator if the denominator has a 0 at x is equal to a, and the numerator is not 0 at x is equal to a, so let's say, for example, 1 over x, okay, so when is at x equal to 0? Well, at 0, x is equal to 0, okay? Or alternatively, if we had, let's say, 3 over x minus 2. Okay, when is that bottom equal to 0? Well, when x is equal to 2, okay? But this top line is also not equal to 0, so 3 is not 0, so that's fine. Okay, we can, then the vertical line at x is equal to a, so whatever the bottom is equal to, so whatever that x is, so x is equal to 2 in that case, there is a vertical asymptote on my graph, or on my function, for my function, at that point there. Okay, so whatever's on the bottom is how I determine whether or not there's a vertical asymptote, unless it's equal to 0 on the top when I substitute that in. So an example of that is x over x, okay? Okay, on the bottom, x cannot be equal to 0, but if I put x is equal to 0 onto there, then I get 0 anyway. So there would be no asymptote for that bit there, okay? So the choice between y, okay. Then, so once we work out an asymptote, okay, so here's my graph. I know I've got my asymptote here. To determine what's happening at this function here, so whether it's going like this or it's going like this, okay, we're just going to make a table of signs to determine what's happening on either side of this asymptote. So, is my graph in the positive over here or negative down here, or is it in the positive over there and the negative down here, okay? So we're going to use our table of signs to do that, like we just looked at in our previous lesson. So once the asymptote has been identified and the behavior of the curve near it then can be described using notation, x is going towards a to the positive and x is going towards a to the negative. So, as x approaches 2 from the positive, y approaches, maybe it's going to infinity. But whereas x approaches 2 from the negative, y is going to negative infinity, just like that. Something along those lines, okay? But the idea is you're using the little plus and the little minus to say which side am I coming from, okay? So am I coming from the positive numbers towards the negative numbers? So am I going from right to left? So that would be for my x is positive or my x is negative if I'm going that way, okay? So x is positive is that, x is negative is the other one. Sketching the reciprocal function. Now, the reciprocal function and the asymptotes have a lot in common because when we're taking the reciprocal of just a regular polynomial, so like x squared plus 1, okay? So the reciprocal of that is just 1 over x squared plus 1. So in other words, when can I not have values to make this true? Like whereabouts on my graph am I going to have these asymptotes? Because remember, the asymptotes is where this function isn't true. So just looking at this one here, I know my bottom is, well, actually, let's go x squared minus 1. Okay, so I can factorize that to be 1, x plus 1, x minus 1, okay? And so that means that I've got 2 zeros here and here, okay, at these points here. Okay, so it means that I know that these values here can't actually be true for this. I know that I can't actually, pop them on the, so when I use x in here and here, I don't actually get a value, so my function won't go like that because this function here, value here, doesn't actually exist. So what happens at these values is I get these vertical asymptotes, okay? So there's going to be 2 in the case of this one. And then what we're going to do is we look and see, well, what does our function do either side of those vertical asymptotes, okay? So basically you need to check, well, what's happening coming in from either side of these asymptotes, okay? Is it getting very big? Is it getting very small? Is it positive or is it negative? And we've just got basically a systemized way of doing that by doing the following things. So when we sketch, we suppose that the graph of the function y of f of x is drawn and we want to sketch the inverse. So just this here, y is equal to, so remember inverse? You may remember inverse cos, inverse tan, okay? Inverse functions have this little minus 1 here. Okay, so the inverse of a function is actually given as f of x and everything is to the negative 1. Okay, so that's the inverse, so that's the reciprocal. Sorry, let me just rephrase all that of what I just said. The reciprocal is whenever we have to the negative 1. So think of like when I have x to the negative 1. Okay, that's the same as writing 1 over x, okay? Or x to the negative 3 is like writing 1 over x cubed. Okay, we did a reciprocal like that. So the reciprocal of a function is f of x, and it's all to the negative 1. Or, in other words, 1 over f of x. Okay, so with that being said, so we're not talking about inverses because that's our next lesson. So it's later on. So what we're doing is we're doing these reciprocals. Now, the new, the new graph has the same size for all values of x. Okay, so if I'm looking at a graph, so I'm just going to draw one down here really quickly. Here's a graph here. It looks like this. It's some random graph like this. Okay, so when I'm drawing the reciprocal, okay, if it is, so here's my zeros, okay, so my zeros are staying the same, but if this part is negative, then that means my reciprocal is going to be negative in some way, okay? I don't know what it looks like, but it's not going to be in the positive area at all. It's going to be negative, okay? So I'm going to put these in quickly because we may as well do this one as I go. So all of them are negative. Now the zeros of y of f of x correspond to the vertical asymptote. So that's what I just did. So here's my zeros here, 1, 2, and 3. Okay, so that corresponds to my vertical asymptotes, 1, 2, and 3. Okay. If f of x is approaching infinity, or f of negative x is approaching infinity, as x approaches infinity, or x approaches negative infinity, the x-axis is a horizontal asymptote to y. Asymptote to f of x, or the inverse of f of x. Okay, so what this is basically saying, if my function is going to infinity as my value for x is going to infinity. So if the further and further I go out here, my function goes closer and closer to infinity, then hang on, that doesn't make any sense whatsoever. I might need to start this again. If f of x approaches infinity, so as my function goes up and up and up, depending on my value for x, so as my x goes across, then the x-axis is a horizontal asymptote to the x-axis is a horizontal asymptote to that. Oh, right, of course. So basically, if you've got your values shooting off forever and ever and ever, okay, like this over here, so shooting off these ways, okay, basically what this is saying is that this graph will never actually go across the horizontal, okay? So if your values for x are getting bigger and bigger, so the further you go these directions, and so if that happens and my values for f of x are also going to infinity, so the further I go out infinity, answers give me infinity, or negative infinity as well, then I'm going to have a horizontal asymptote at this point, or on the x-axis, okay? So basically, when I draw my line, what I'm saying is that there is no point at which my graph is going to cross over the the horizontal axis, okay? So there's no point on which that's going to happen. Now, if f of x is going towards b, which is not equal to 0, as x goes to infinity, so basically, what it's saying is, so if my function over here, so if f of x is going towards a number, so basically, if I go towards my infinity, but instead of this function shooting off to infinity, instead, it sort of curves off and sort of starts going like that and getting flatter and flatter, then my horizontal asymptote is just the value at which my function is getting closer and closer and closer to, okay? So, if, like a square root one, well, not a square root one, it's not a really good example, but, there are some functions in which, as they go up and up and up like that, okay, they're going to get to a point where they're never actually going to touch a specific value, okay? In this case, something other than 0, okay? Then that's going to make an asymptote like that, okay? Now, it's the same for the negative as well, but going in the negative direction. So if there's if this function comes down like this and starts going off like that, where it's getting flatter and flatter and flatter, then there's a horizontal asymptote going like that as well, okay? Now, back to my picture. When one curve intersects at y is equal to 1 or y is equal to negative 1, so does the other. So let's say that y is 1 is there and y is negative 1 there, okay? Look for the values where my line is, or where my function is going through those values. That's where my inverse function also goes through those values. So 1, 2, 3, 4, and 5, okay? So if this is 1, this is negative 1, then my values on these ones also go through those values too. So there's one that goes here, there's one that is here, there is one that is here, and there's one final one that is a bit closer than that, okay? So wherever my function goes through 1 or negative 1, there's one over here too, and that is on this side of the 0, so it would be somewhere like here, okay? So wherever my function goes through a 0, okay, wherever my function goes through a 1 or a negative 1, then it also goes through that on that value as well, okay? Because remember, the inverse of 1, the reciprocal of 1 is 1 over 1. So remember, 1 over 1, we flip the sign, or flip the fraction around, we get 1 over 1. Or negative 1 over 1 is the same as 1 over negative 1, which is just the same as negative 1, okay? So those reciprocal values will be the same regardless of how you do this. Okay, when one curve is increasing, the other is decreasing, okay? So as this curve goes up, this one comes down. That's it. This one is going down, this one is coming up. It turns around here, it turns around here and goes back down. This one's going up. This one, so you see this one, how it's actually, even though even though it's... No, never mind. So this one here, so here's our 0 here. From here to my first point, it's coming down, it's coming down, it's coming down, and then it peaks off down here, so it's going to peak off here, and it's going to shoot back up to my asymptote down there. And then this one here, well, that's decreasing, it's going to go like that, okay? So, I mean, that was a lot to take in, and we're going to do an example of this anyway, but that's pretty much what my reciprocal looks like, okay? So it's a bunch of different disconnected graphs that make up this one. So the key points are, my asymptotes are at these values along here, okay? So where my zeros are on my original graph, okay? My values for 1 are still where my values for 1 are on the other graph, okay? If x is decreasing, sorry, if f of x is increasing, and then I keep screwing this up. The reciprocal is decreasing. Okay, so this one's going up, so this one's coming down. This one's coming down, so this one's going up. Basically, you're doing the opposite, okay? This part of the graph is positive, this part of the graph here is positive. Okay, the last thing that I want to say is when the curve has a local maximum, the other has a local minimum, okay? So over here, what that means is just that, you know, this one, it has a top before it comes back down, so this one has a bottom before it comes back up, okay? So it's just like, it's like the opposites. Okay, reciprocal, think of like the opposite. Okay, so the domain, okay, so domain, which is a really cool thing about these functions is if you know the domain of this guy here, okay, the domain of the inverse is exactly the same, except without the zeros. So like, you know, I can't put these in because I can't put them in the regular function. That's it. Okay, so hopefully that's helped you with that. Let's go through a few examples now. Okay, so find the vertical asymptote for the function y is equal to 3 over 2 minus x, okay? So so this is part A, so y is equal to 3 over 2 minus x, okay? So x cannot be equal to 2. So vertical asymptote is when x is equal to 2. Okay, construct a table of signs and describe the behavior of the curve near it. Okay, so table of signs, just like a table of values. And in fact, for this one, we only need 4 parts. We need the asymptote, so 2, and we need something either side it to check what happens, okay? So table of signs, we don't care about the actual value, we just care about what the sign is. Now substituting 0 into my original equation, y is equal to 3 over 2 minus x. Substituting 0 in, we get 3 over 2, so that is positive. Putting 4 in, I get 3 over 2 minus 4, which is just 3 over negative 2. So in fact, that one is negative. Positive divided by negative is negative. So it's my table of values. So it's positive when, so x, so positive when x is less than 2, and negative when x is greater than 2, okay? Not equal to because we're not including 2, but when it's less than or greater than. Name the horizontal asymptote and describe the behavior of y for large x. Okay, so this is just a regular rectangular hyperbola. Now we know that for this one, that the horizontal asymptote is 0, okay? And we can test that by checking very large numbers of x and very, very small numbers of x. So using that rule from before, horizontal asymptote, if and only if, or if, I feel like I'm missing a few letters there. Asymptote when x is equal to 0. So if my top value is different to my, so if I put 0 down the bottom, sorry. What was the rule for that one? Let's just double check that. So back over here it says, so here we go. If f of x, so if it's increasing or if it's going to infinity, and infinity, So this is my main one I'm looking at. If f of x goes to infinity or f of x goes to negative infinity as x goes to infinity or negative infinity, then the x-axis is a horizontal asymptote to y of f of x. So the way that we're going to check that is we're going to actually look and see what happens as we put in big numbers. Okay, so what does this number go to? So if I effectively put in a big number in here, so let's say x is equal to 1 million. Okay, what happens to my equation? So what happens when I put that in? I'm going to do that on my calculator really quickly. Okay, so we're going to put that in. We get calculator, and we say, so 3 divided by 2 minus 100,000. So that's divided by negative, like what? 9,999,998. Like, it doesn't really matter. Like, we know it's big. And we get that that is equal to a very, very, very large negative. So basically, as x approaches infinity, negative infinity, no, infinity, because we put in a very big letter, y goes to, so we put a negative number in there, and it's getting really, really, really tiny, and it's 3 divided by a really massive negative number, so it's actually going to be a very small negative number. And as x approaches negative infinity, y is going to approach 0 from the positive end, okay? Because it's going to be the same thing, but just like it's going to be a really big positive number. So remember going back to this thing over here, okay? So the reciprocal of a positive number is a positive number, and the reciprocal of a very small number is a very large number. So if I've got a very small number on the bottom, so like a very, very large negative number, if you will, then that value is equal to a very small number, and vice versa. Okay, so that's that. Last but not least, sketch the curve. Okay, so we're going to sketch the curve. I'm going to draw up a thing like this. Okay, now we know we've got a vertical asymptote when x is equal to 2. So 1, 2, like that. So there's my vertical asymptote drawn correctly. Okay, so basically none of my graph is going to pass this one here. I've also got a horizontal axis here. I know 1 is going to be equal to 1, so at 3, my thing will be equal to something, and at 1, my thing is going to be equal to something. Okay? So as x approaches infinity, y goes towards 0 and 0 and 0. So as my value for x gets bigger and bigger and bigger, okay, my value for this gets really, really, really small. And it's actually coming from the negative side. So that means it's actually going to be down here. Okay, so my graph for this one's going to look like that. Whereas the other side, okay, as x approaches negative infinity, so as x goes this way, y is getting closer and closer and closer to 0. Okay, so the difference between this and this is getting closer and closer to 0, but from the positive side. So positive being the above side. Okay, so as we go this way, so what happens when I get closer and closer to 2? Well, it's getting bigger and bigger and bigger, so it's going to look like, not that, but it's going to look something like that, okay? And so there it is. And we know it looks like that because it's just a regular, a rectangular thingo. Now to just to double check that this distance here is actually going up and down, what we're going to do is we're going to check either side. So as x approaches 2 from the negative side, so as it gets closer and closer here, so let's put in a number that's really close to negative 2, or sorry, a number that's really close to 2 coming from the negative, so like 1.9999999. If you substitute that into my original equation up here, you should find that you get a very, very, very big number. So in other words, getting higher and higher and higher. And as x approaches 2 from the positive side, so I should finish that off. F of x, or my function, approaches infinity because it's going up. And so try 2.000001, okay, for example. So I don't know that arrow there. In fact, it actually makes it so that x is going to approach negative infinity, just like we have down there. So you just have to put those values in the function to get that. So basically, that's how you draw these things. I know it's been a pretty hastily done one. My examples didn't really help me on my side, but that's all good. So that's example one. That's how you draw, one of these rectangular hyperbolas. Just follow the steps. Okay, make sure you do sort of all this part before you actually just go ahead and draw it. But yeah, so that's how you do that bit. Example 2 is a bit easier, thankfully. Well, I think it's a bit easier anyway, because it's actually just sketching the reciprocal. So we're given a function, we just have to sketch the reciprocal. Okay, so you can go back to the other side and you can check the steps. But I'm going to do the ones really quickly that I know, or the way that I would do it, just straight up. Okay, so we look for the zeros first. So there's a 0 at -1, there's a 0 at 1, and a 0 at 2. So I'm looking for -1, I'm looking for 0, and I'm looking for 2. So those are where my vertical asymptotes are. One here and one down there. Okay. And there's also one at 0, but because I can't really put a dotted line on 0, I'll try and put one sort of next to it to remind ourselves that there's one at 0. But remember, that one is on 0, it's not there. Okay, so where this thing goes through 1, my function goes through 1 as well, or -1. So here's -1. So if I go to my original function and just draw a line through -1, and I draw a line through 1, I can see it goes through 1 at one point, which is just past the 2, like literally just past the 2. So if I put 1 and -1 here, so like probably just here. Okay, and let's have a look at where my negative ones are. So there's a -1 here, here, and here. So there's a -1 just after the asymptote on this side. There's a -1 just after the 0 here, and just before the 2 here. Okay, so those are my 4 points where my 1 is equal to 1. So now we're going to look at the increasing and decreasing. So remember, when my function is increasing, my reciprocal is decreasing, and vice versa. So starting from left to right, so this one is going up, it is increasing. So my function on this side is going to be decreasing like that, if I could draw it better. Okay, so something like that, but also make sure that it's, because remember, it's not actually, it's getting closer and closer, but it's never actually meeting them. So it should go through that point there. I'm going to give it one more try to draw this. So, for God's sakes, something like that. Okay, so it's like that. Now, in this bit, it's increasing for the first bit, and then it's decreasing for the second bit between the 2 points. So, if it's increasing, it starts off by... Oh, hang on. Oh, yeah, that's this bit in here. So it's never actually is going to get down to the 1. So because all these numbers are below the 1, it's never actually going to get through my 1 value here. Okay. So increasing here, decreasing here. So basically something like this, but again, drawn properly. Something like that for that middle bit. Okay. My next bit, okay, it's decreasing here. So in this case, it's going to be increasing here. My maximum is just after my 1, so my minimum point for this one is just after the 1 as well. So this one's going to look something like this. Okay. So something like that. And the last bit, my 2 is increasing. So from the 2 onwards, it's increasing all the way. So this one's going to be decreasing all the way. Like that. Okay. And so there is my reciprocal function. Okay. So yeah, like it is a bit tricky to begin with, but like if you just follow the steps, you'll be able to draw all these without much of an issue. Okay, so I don't have an example when there are some horizontal asymptotes, except for the ones where it's equal to 0. But look, I'm sure you guys can work it out. If not, I can go through an example in a bit if you guys would like that. But I have faith that you can do it. So have a go, see what you can do, and I will talk to you in the next video.